The difference in the mass of the calculated mass and the experimental mass. There is some difference in the mass will be there. We call that mass as a mass effect. And where this mass has been disappeared, so he says that according to Einstein's mass energy equivalence, this mass has been converted in the form of energy. We call that energy as a binding energy that help me to bind the neutrons inside the nucleus, or we can say that it is the energy required to separate the neutrons from the nucleus. So that is about the binding energy. So after studying about the binding energies and curve, and we understood that if any element is having more binding energy, means it is what? It is stable and non-radioactivity. It will not undergo any radiation. But if the element is having less binding energy, means then we can say that it has what? It is unstable and will start emitting radiation. We call that as a radioactive elements. Right? So there are some are naturally occurring radioactive elements, or there some are artificially we are doing it. Right? We are bombarding it with uranium metal. We take it means we are bombarded with the particle, and from that the nuclear fission and the process will take place. Right? But some would like radium, polonium, like that. If we place it immediately outside it, immediately it will start emitting its radiation. So some element has a nature inbuilt capability that what? So it will start emitting its radiation. When they are unstable, they will emit some of its energy from it to become very stable. Right? We call that by emitting the radiation, it will emit the radiations like alpha, beta, and gamma radiations. Now we are going to study deep into it. And in the binding energy curve, we studied thoroughly about that, and the mass number rising from 0 to 20 is sharply increasing, and from 20 to 40 or 40 to 120, it is what? It is somewhat remaining flat, and after 120, it has been what? Decreasing slowly. Therefore, we are saying here what? When Z stands for what? Z stands for atomic number. The element whose atomic number is greater than 82. So, atomic number whose element is greater than 82. Yeah, so we say that from that value, the stability of the atom starts to decreasing. Therefore, the nucleus is what? Unstable. Therefore, that type of elements will involve with the radioactivity, and some are natural radioactive elements. When I keep it in outside, immediately it starts emitting its radiation. Is it clear to you? So that type of elements are said to be what? Radioactive elements. So now we are going to define about this radioactivity. What is meant by radioactivity? It is a phenomenon of spontaneous emission. So what is meant by spontaneous stands for? Spontaneous means what? Automatically it is taking place. Means we call that as a spontaneous. There are only two types of work. One is called as spontaneous and the other is called stimulated. So spontaneous means without anything else, naturally it is happening for me. We call that as called as spontaneous. Right? So automatically, immediately it is happening. Right? Stimulated stands for what? By means of continuous bombardment, or by means of continuous bombardment of anything, it will start to emit a radiation. We can call that as what? Stimulated based emission. Here in radioactivity, it is said to be what? Spontaneous emission of highly penetrating radiations. We take laser number means it will what? Stimulated emission. Right? It's not a spontaneous emission. Laser light will come out of that thing with the help of what? Stimulated emission. That we have to continuously force on to make the beams to come out from that light. So we call that as a stimulated emission of radiation. But radioactivities are the spontaneous emission of a highly penetrating radiation. What is penetrating stands for? Penetrating radiation. Right? The phenomena of a spontaneous emission of highly penetrating, that is very dangerous radiations such as alpha, beta, and gamma rays by elements. We call that type of thing as what? Radioactivity. And elements which possess this nature, we call that elements as what? Radioactive element. For example, what? We can take radium. Is it clear to you? So these are what? Radioactive elements. If we place it outside the radium, immediately it will start giving what? Alpha, beta, and gamma radiation. Towards the right, it will give rise to alpha. Towards the left, it will give rise to beta. Then central particle, it will be what? Gamma. Right? So immediately it will start emitting its radiation. We call that type of phenomenon as what? radioactive, and elements which emit this called as what? Radioactive element. Is it clear to you? So, from the binding energy curve and the mass effects, we understand the conditions that some elements are unstable in nature, and these unstable elements will automatically by nature what it will do? It will release its energy and it becomes to be stable. Right? So, what type of energy it is releasing? It is releasing some of the penetrating radiations like what? Alpha, beta, and gamma radiation. We call this phenomena as the spontaneous emission of phenomena as what? Radioactive emission, and we call the element which is doing this is called as what? Radioactive elements. Right. So some of the isotopes, right? So many elements and the isotopes undergo these emissions, and these isotopes which have been formed by naturally emitting radiations have been used in various fields for various applications. Right. So some of the common things is said to be what? It is helping in carbon dating. So we'll study that later, right? We will find the age of a specimen, right? So when it has been done by means of sedimentation, they will find about what? So how far it has been, how many years the thing has been lived, so how back it has been get settled and so from back it's called as what? Carbon dating, or we call it fossils, right? So also it helps in cancer treatment, right? Apart from that, it has been used in agriculture in order to yield the crop fields, right? And also it has been used in vegetables or some other things in order to remove or frequent spotting and spoilage of food at various types, and it's used in skin treatments, and many radioisotopes have been many advantages over it, right? So that's why some of the isotopes has been naturally made and some of the isotopes are artificially produced using what? Laboratories. Right? So based on that, its applications and thing has been just widened over, and it settles some new conditions for that, right? So that is the condition of what? Uses of radioisotopes. So radioisotopes has many applications like carbon dating, cancer treatment, in agriculture helping to yield very frequently. The crop yielding can be increased more, and it can provide the sprouting and spoilage of vegetables or fruits or any other things, and also it has been used in various ways of treatments in medical diagnosis and also in various engineering fields. Also, the radioisotope plays a very vital role in various applications, right? So that is the thing. Then we can say that when any radioactive nucleus undergo decays, if anything, if I place a radium oxide, there are automatically undergo decay. If it is undergoing decay, then automatically the mass of the initial nucleus before decay will be greater than the sum of the mass of a final nucleus and also that of the emitted particle. If I get the equation, the reactant and product side, always the reactant side mass will be what? More than that of a product side. So where that mass has been disappeared, so we call that mass which is disappeared is called as what? Mass different, and the mass has been converted in the form of what? Energy. Is it clear to you? So therefore, automatically, if I given the equation, we can say is that the mass of the parent or an initial nucleus, so will always will be greater than the resultant mass of a sum of a resultant final nucleus and the carbon element. That is the condition for a radioactive substance too. So where that mass has been disappeared, so that mass has been converted completely in the form of what? Energies. So this radioactive concept has been first given by whom? It is given by Henry Becquerel, and later Marie Curie and Pierre Curie both studied about various concepts on this experimental basis, and they revealed all the conditions for what? Radioactive substances. Right? So there are three types of radioactive decays we are going to learn in this lesson, and each one will be a separate part of your final questions, and very important concepts too, but also very easy concepts to understand and write. Simple knowledge. So only we have to stretch the writing, that's all, right? So only one concept we are going to learn, and we are going to write a 5 marks, we are going to stretch it with the examples, that's all. So very simple and very easy and frequently asked basic questions is what? The decay concepts. So what are they? So there are three types of decay concepts will be there. One is called as alpha decay, beta decay, and gamma decay. So the word itself will convey what it is. So alpha stands for what? Helium nucleus. So when an element start giving out of helium nucleus as an end product, we call that type of emission of radioactivity. It is called as what? Alpha decay. Right? It is all natural occurring. It is not a made by bombardment or any other thing. So all are natural Alpha decay. Then what is going to be beta? Beta stands for electrons or positons, right? So in either there are two types of beta decay we can classify. One is said to be beta minus decay, another one is called as beta plus decay. So beta minus decay means it will emit the electron. So minus stands for what? Electron, right? So the same thing in the positive manner. We call that a special name called what? Positron. We call it a name called what? Positron, right? So E minus stands for electron. E plus stands for positron. If a decay give rise to electron means we say that decay is what? Beta minus decay. If it give rise to beta plus decay means it will emit what? Positron. So along with this electron and positron, automatically one other thing will be included and we call that as a neutrino. So what the neutrino stands for? There are two types. Always there will be what? Particle and antiparticle will be there. How we are saying human being. Human being exists for them said devils, right? The same structure but that doesn't have any mass also we call that as a boson. Like that all the particles of elementary particles in nature will have antiparticles, right? So if I say neutrino, antineutrino. If I say electron, positron. The same nature of thing but will have opposite nature before that is what? So antiparticles. So electron always will be accomplished by antineutrino and a positron will be always accomplished with what? Is a neutrino. So today we learn what about a neutrino. We are going to learn about detail about these decays. Right? So what we have studied now? We have studied about two decays. One is called as alpha decay, another one is called as what? Beta decay. So alpha decay stands for what? Helium nucleus. If any radiation start giving out our helium nucleus group, then that type of decay is called as what? Alpha decay. Then if we say for beta decay, what it will be? There are two types of beta decays are there. One is called as what? Beta plus decay and beta minus decay. So beta plus decay will give rise to end product of positron and neutrino, and beta minus decay will give rise to end product of electron and antineutrino. So that type of decay is called as what? Beta decay. Then the last one is gamma decay. What is the gamma decay stand for? So gamma decay is nothing but only a change in the energy level between the parent nuclei and the daughter nuclei, but the mass number and atomic number will remain the same here. So that type of decay, only the energy difference is taking place between these end products. We can call that type of decay as what? Gamma decay. Right? So here I have written that theoretical equations for that, but we are going to see very detailed about each and every one because each one is a separate final question and it's a very important condition. We are going to repeat the same condition, right? So if the decay is going alpha decay is what I know. So it is going to emit helium nucleus. Helium stands for what? He24. So this is number 4. This number is what? Mass number. 2 gives you what? Atomic number. So we can say that when the mass number has been decreased by 4 and the atomic number has been decreased by 2, then that type of decay is said to be what? Alpha decay. So the skeleton equation, right? Skeleton equation is the base of the equation. So this is a parent one, that is our initial one. So initial one, so in that mass number will be decreased by 4. Decreased by 4 means what? Minus 2. And the atomic number will be decreased by 2, minus 2. Then in order to have a stoichiometric or balancing of an equation, so we'll have what? Helium nucleus. See that? So if A minus 4 plus 4, it becomes Ta. Z minus 2 plus 2, it becomes Tz. So both sides. So what is happening? The charge, the total mass of the mass number and atomic number remain the same. That is the condition, right? So both left side and right side should be remain the same. That is called as balancing of an equation or stoichiometric equation. So what is happening? This element is giving rise to what? Helium nucleus. Therefore, we call that type of decay as what? B alpha decay, right? Then come for beta decay. So beta decay, there are two types of beta decay will be there. One is called beta plus, another one called beta minus. Now we'll see beta minus decay. So this is element. So mass number, atomic number. Mass number will remain the same, but atomic number will be increased by 1. So we have increased by 1. So we have to remove that. So therefore it has an electron. So what is electron? Initially we will have E minus like this. They will write E minus. So E minus stands for what? Minus 1 e power 0. So add A plus 0 becomes A. Z plus 1 minus 1 becomes Z. So automatically the equation has been same. But along with this electron, automatically there is a pair here. We call that as an anti-neutron. No. Always it will come as a combined effect in it, right? So this is also laterally proved by scientists how why it is coming. So that is some they have been calculated energy. That is some missing of energy is that. So that missing energy has to be taken by whom? This anti-neutrino. Is it clear to you? Step. Beta plus decay. Beta is again mass number remains same, but atomic number will be decreased by 1. So you want to compensate the decreased one, a positive value for electron has been there. We call that positive value as what? Positron. So along with the positron, automatically another thing is called as what? Neutrino. Then this type of decays are called as what? Beta decay. Beta plus decay and beta minus decay. And last one is a gamma decay. So gamma decay is a 1. So both mass number and atomic number will remain the same, but only there is a change in the energy from a daughter nuclei to a parent nuclei. So we call that decay as what? Gamma decay. Right? Now we are going to study this very detailed about alpha decay, beta decay, and gamma decay. So remember that depending upon the binding energy and the mass difference, we studied that with the atomic number of the element who is having atomic number greater than 82 has the capability of what? So radioactive elements, right? So we say that some are unstable in nature. So due to making them to be stable, it starts emitting its radiation. So we call that type of radiation as what? So radioactive elements, right? So this again we studied about what condition we studied about. The mass of the initial nucleus will always be greater than the sum of the final nuclei. Right? So here then we studied about the 3 kinds of decays: alpha decay, beta decay, and gamma decay. We are going to see one by one. Now first we will see about what? Alpha. So now we are going to study about the alpha decay. So we already learned about the alpha decay. So what we have learned? So we have learned that the emission of helium nucleus is said to be what? Alpha decay. Right? So and also we can say that there is a loss of 2 protons and 2 neutrons will give rise to the helium nucleus. So we are saying that alpha, the word, if you hear the word alpha, you have to immediately call upon what? Helium nucleus. Right? So this is a skeleton equation that we have already seen. So XA2 is a A stands for what? A mass number. Z stands for atomic number. And X is called as what? A parent nucleus. So when this element is undergoing decay, this everything is what? A natural decay or spontaneous decay. That means without any bombardment, the particle or its own will start emitting its radiation in order to make them to be stable. Right? Therefore, if it is losing 2 protons and 2 neutrons means the mass number will be decreased by 4 and atomic number it will be decreased by 4 and the atomic number will be decreased by what? 2. That will give rise to what? A helium nucleus. So A stands for mass number. The mass number will be decreased by what number? Decreased by 4 and atomic number will be decreased by 2. That give rise to what? Helium nucleus. We call this Y as what? A daughter nucleus. Right? So now we can see this trigonometric of the equation. Both sides, left side, reactant side and the product side, the value will remain the same. So we see that A minus 4 plus 4, it becomes 2A. Z minus 2 plus 2, it becomes to be what? Z. So we call this type of equation as what? Stoichiometric equation. So this type of decay is called as what? Alpha decay. So alpha decay is nothing but the nuclei or elements start emitting its helium nucleus. Is called as what? Alpha decay. For example, if I take uranium 92 and 238. 238 is what? A mass number. 92 is what? Atomic number. So after undergoing alpha decay means what has to do? So mass number should be reduced by 4. So 238 minus 4, it gives to what? 234. 92 minus 2 give rise to 90. Therefore, the element, the daughter nucleus will be thorium. So uranium, in order to become stable, it starts emitting its radiation. So it gives rise to a new element called what? A thorium element. Along with that, we will get what? A helium nucleus. So we call this type of decay as what? An alpha decay. Right? Then if we want to say that what? Already we learned that what? The mass of the parent nuclei will always be greater than that of a daughter nuclei. Therefore, the difference in the mass is said to be what? Mass defect. How to get the mass defect? We have to subtract the product with the reactant. So it becomes delta that is mc square. So we have to write delta into c square. So that is the energy calculations for what? The value. Now we are going to say that the Q value should be greater than 0 if the emission is said to be what? A spontaneous emission or naturally occurring emission. Right? So Q is greater than 0 means then that type of emission of radioactivity is called as what? A natural emission of radiation or a spontaneous emission of radiation. Right? So therefore alpha decay process is also what? A spontaneous emission. That also the Q value should be greater than 0. Right? Therefore, we can say that the disintegrated energy Q is also equal to the kinetic energy gained by the nucleus. So, kinetic energy gained in the decay process. Therefore, we can say that if a parent nucleus is at rest, therefore, total kinetic energy will be the summation of a daughter nucleus and the alpha nucleus. So, we call that condition as what? So, spontaneous decay condition. So, if it is a spontaneous means what? Automatically happening. So without having any stimulation, without having anything, so immediately it start responding to it means we call that type of emission as what? Spontaneous emission. In spontaneous emission, the Q value, the disintegration energy value should always greater than 0. So that is a condition we learned. So in alpha decay also is a spontaneous emission. Hence here also the Q value should be what? A greater than 0. And also we are saying that this disintegration energy is also linked with what? The kinetic energy gained by the nucleus. So the total kinetic energy will always remain to be what? Constant, right? Therefore, if suppose we are saying the condition the Q value what we are finding is less than 0, not greater than 0 means, then we can say that the process is not spontaneous. This is not spontaneous means what? It's not occurring by nature. So decay process cannot occur spontaneously. Therefore, energy must be supplied to induce the decay. We have to externally we have to provide the energy in order to stimulate the decay. We will not call that name as spontaneous. We will call the name as what? Stimulated emission. Like already I said, wave emission is what? Stimulated emissions. We have to go on giving a form of energy to it. Then only from a level of excited state, we will jump to a polar state. Give rise to what? In phase radiation. We call that as what? Laser. Right? So that is a separate concept. We will not able to confuse that. So what is spontaneous and stimulated? That is very best example to understand that. Right? So that is about an alpha decay. So alpha means it is a helium nucleus. So a parent nucleus that is going to give rise to a helium by losing of 2 protons and 2 neutrons means we call that type of decay as what? Alpha decay. So alpha decay is a spontaneous decay, that means naturally occurring decay. So everything, so without having any compartment or so it starts losing this energy in order to make them to be stable. We call that type of decay as what? Alpha decay. So that is a change in the mass between the reactant side and product side. We call that change in mass as what? Mass effect. So where that mass has been spent? This mass has been spent in the form of energy. We call that energy as what? Disintegration energy. So the disintegration energy is represented with a symbol called what? Q. Right? So the Q value should be greater than 0. We can call that type of emission as what? Spontaneous decay. So in the spontaneous or natural decay, Q value should be greater than 0. And if the value is less than 0, then that type of emission is not a spontaneous emission. So we have to stimulate, we have to supply energy from external in order to stimulate that emission. That is about what? Alpha decay. So very easy and simplest questions and involves in 5 marks also. So that is a knowledge. We'll go for what? Beta decay. So there are 2 types of beta decay. We'll see now. Surrender. So now we are going to discuss about beta decay. So already we have discussed about what? Alpha decay. Now we are going to discuss about a beta decay. So there are 2 types of beta decays are there. One is called as what? Beta plus decay and beta minus decay. Right? So what is beta plus decay stands for? When decay takes place with the emission of electrons means, then that type of decay is called as what? Beta minus decay. And when the emission of positron is taking place means, then that type of decay is called as what? Beta plus decay. Therefore, beta decay involves what? radioactivity which involves the emission of electron and positron. Electron or positron. We call that type of radioactive emission as beta decays, right? So very simple. Alpha decay means emission of helium nucleus. Beta decay means emission of either electron or positron. So electron takes a negative value. So beta minus decay means it's electron, beta plus decay means it is positron. So we have already studied the electron and positron are said to be antiparticles. So electron will be represented symbol of what? E minus. Positron will be represented symbol of what? E plus. So both are said to be antiparticles. Positron is nothing but what? It is an antiparticle of electron. So that means what? The mass will remain the same, but only there is a change in the opposite of charges, right? There will be change in the charges will be there. They are opposite in nature. So that is the only difference between a particle and an antiparticle. Right? Therefore, we say electron and positron as a beta particle since it is coming out only due to what? A beta decay. So we call these particles as what? A beta particles. So what is beta particles? The electron and positrons are called as what? Beta particles. Is it clear to you? So what is antiparticle stands for? Antiparticle means the mass will remain the same, but there is a change in that in the opposite, or the charge is opposite to each other. Then that type is called as what? Antiparticles. Right? Is it clear? So already said by us, right? What we said? So human being and devil. So devil will have what? Or devil or ghost will have what? The same structure of a human being, but doesn't have a mass. Right? So we call that as an antiparticle of a human being. Similarly, all elemental particles have this antiparticle. So each one will be varying in a certain category. Here it varies the same mass, but the charge will what? Differ with each other. We call that particle as what? Antiparticle. So electron antiparticle is what? Positron. And electron and positron both are called as what? Beta particles. Now let's study about the beta minus decay. Beta minus decay means what? The emission of electron is said to be what? Beta minus decay. So what is happening? The mass number will remain the same and the atomic number will be increased by 1. So then we see the skeleton of the equation. So this is A stands for mass number, Z stands for atomic number. So A remains the same. Atomic number will be increased by 1. So in order to balance the equation, there should be 1 minus should be there. So that minus has to be taken by whom? The electron. So actually E minus can write off equal to 0. So that both symbols are right. So shortly will be very short. A plus 0 will be A. Z plus 1 minus 1 will be Z. So along with electron, there will be another particle emitted. We can call that as what? Anti-neutrino. Right? So we are saying that neutrons in the Z, that is a paranucleide Z, neutron in the Z has been converted into proton by means of what? By emitting an electron and anti-neutrino. So that is something happening, right? So what they are saying? The neutron in the paranucleide has been converted into what? Proton by emitting an electron and an anti-neutrino. So that is a process. Therefore, another equation we can write. N stands for neutron. Neutron has been converted into what? Proton with the emission of what? Electron and anti-neutrino. So P stands for proton. E minus stands for electron and U bar stands for anti-neutrino. So we are saying in beta decay, beta minus decay, we are saying that the neutron in the paranucleide, that is X. So the paranucleide will be automatically converted into what? Proton with the emission of what? Electron and anti-neutrino. If we take an example, we will get carbon. So carbon C614 is an isotopic form, right? C12 means is a real one. C14 stands for what? Isotopic form. This is a one of the most thing which involves in what? Carbon dating and everything. So C16 is automatically undergo disintegration. Most of the isotopes will undergo disintegration. So then here as per the beta minus decay, the mass number will remain the same, but atomic number will be increased by 1. Then which is having 7 value, nitrogen, so due rise to N14 with the emission of what? With the emission of electron and anti-neutrino. These kind of decay process is called as what? Beta minus decay. Is it clear? Very easy, very simple. Yes. So it is what? What is happening? The mass number will remain the same and the atomic number will be increased what? Proton by emitting an electron and antineutrino. Right, now we see about beta plus decay, opposite to this beta minus decay, right? So what is that? Xa to Z, right? So paranuclear. So here the mass number will remain the same, but atomic number will be decreased by 1. In beta minus decay, what is happening? It is increased by 1, and beta plus decay has been what? Decreased by 1. So in order to balance the equation, that should be positive 1. Plus 1 should be there. That has been provided by whom? Positron. Along with positron, who will come? Neutrino will come. Therefore, here also we are saying that a proton from the parent nucleus has been converted into neutron by the emission of positron and neutrino. So what is happening in beta minus decay? Neutron has been converted into proton. But what is happening in beta plus decay? Proton has been converted in terms of neutron. So by emitting E plus and E plus means what? Positron and neutrino. But what is this fact we have to understand here? No single proton will be cannot be what? Involved in this beta plus decay, because due to the energy conversion, we know that neutron mass is somewhat higher than that of proton mass. So no proton inside the nucleus, no single proton inside the nucleus cannot involve in this process due to this energy conversion. So beta plus decay will not frequently take place, but we can say that beta minus decay can take place because beta neutron have what? Higher mass. So neutron has been converting into proton. We already studied by studying the introduction. We learned that the neutron has been stabilized or by means of what? By conversion into proton. Conversion into what? Proton. Therefore, neutron gives rise to proton by means of emission of electron and antineutrino. So what we understood from that? So no single proton present inside the nucleus cannot involve in beta plus decay in order for an energy conversion, but a single neutron can be involved in beta minus decay because the neutron mass is what? So not nuclear mass, it is a neutron mass is what? Greater than the proton. So that is the thing. That's why beta decay is most popular. They say about what? Beta minus decay. They will not go for beta plus decay because single proton will not be involved in this process where it is inside the nucleus. Is it clear? Therefore, beta decay means immediately they will say about what? Beta minus decay, which will be frequently taking place because neutron always tend to convert into proton with the emission of electron and antineutrino. Is it clear? So therefore, what is the equation we can write? Proton converts into neutron plus positron plus antineutrino. So P stands for proton, N stands for neutron, E plus stands for positron, and U stands for what? Neutrino. So neutrino and antineutrino are what? Antiparticles. Similarly, electron and positrons are what? Antiparticles. Again, we are going to see an example here. Na stands for what? Sodium. Sodium 11, 22. Mass number, atomic number. So what is the condition for beta plus decay? The mass number will remain the same, but the atomic number will be decreased by 1. So 11 minus 1 becomes 10. In order to have a balanced equation, we will have what? A positron and a neutrino. So this type of decay is called as what? Beta plus decay. We call this decay as what? Beta plus decay. So it is a very important concept, and this beta decay concept will introduce a new term called what? Neutrino and antineutrino. Now we are going to study that why this neutrino comes. Initially, every scientist has been written this equation without this neutrino concept. Later, by studying this energy and momentum concept, they found that some energy has been missed over, therefore that has been taken place due to what? Neutrino. Later they found and they classified about the properties of neutrinos. Then next we are going to see about what that neutrino is. Then we will go for normally. Right? So I hope you have been clearly understood about what? What is the radioactivity and what is an alpha decay and what is a beta decay, right? So beta plus decay and beta minus decay. So that are both the things. Alpha means the emission of helium nucleus. Beta minus means emission of electron and antineutrino. All this tell jointly, right? Electron and antineutrino. And beta plus decay means emission of what? Positron and neutrino, right? Now we go for the neutrino concepts, right? In beta decay, we learned about a new thing called what? Antineutrino and neutrino. So what is that neutrino and only the electron will be present. So I can say that when neutron start converting into a proton, it emits only electron is the initial prediction. But they are saying that the kinetic energy of electron which is coming out of the nucleus did not match with the experimental result. So we studied beta plus decay and beta minus decay. Beta minus decay we studied that it will release the electron and neutrino. And beta plus decay we studied that it will emit what? Positron and neutrino. These two things will not remain inside the nucleus. It will automatically come out of that. So therefore they are saying that the kinetic energy of the electron which is coming out of the nucleus is not matching with what? The experimental result. Therefore they are saying that the equation is something is missing over. Right? Can you understand that? You already studied that. Beta plus decays. The proton will not frequently convert into neutron. A single proton will not frequently convert into what? A neutron. Therefore, beta plus decay we are not discussing about. So, beta minus decay, the neutron will be converted into electron and neutrino. But initially they said that when neutron is converted into proton, it emits only what? Electron. But they found that some value is missing over that. So they have a twist and a puzzle in that, and later some scientists prove that there is a third particle has been missing over that. So we call that third particle as what? Neutrino. Is it clear? So what they are saying initially they have written like that, and they say that the kinetic energy is not what matched with the experimental result. They compare it with the alpha decay. If they say that alpha decay, they say that the alpha particle has only a certain allowed discrete energy values have been there. But if I see for a beta decay, it gives rise to a continuous range of energies. So by means of conservation of energy and movement, it gives only a specified single value for electron energies and the recoiling nucleus. Therefore, we can say that is a conservation of energy and movement or violated, and we have a question that why the energy of a beta particle have a continuous range of values. So this question has been a puzzle to all the scientists who have been studying this field. So what they are saying, in beta decay, alpha decay, the alpha particle shows us what? Some allowed discrete packets of energies. But the beta decay shows about a continuous range of energies. As per the law of conservation of energy and momentum, they said that what they are saying, it gives a specified single value for electron energies and recoiling nuclear one. Right? So, but as per the conservation of energy, so the thing has been conservation of energy momentum concept has been violated in that. So that there is a question to all the scientists that so why the energy of beta particle have a continuous range of energy. So that question has been in 1931 by experimentally and theoretically W. Pauli has been eradicated or given an answer for that puzzle, and he said that there is one other particle has been existing in the decay process. He said the particle, he doesn't know what is the name of the particle and what is the nature, he doesn't know, but he predicted that there must be one other third particle should be present along with the equation, and he named the third particle will always carry the missing energy and momentum. So he is the first person to lay the foundation that one other particle will be there. So that particle only carries the missing energy and momentum, right? In order to confirm about what? The law of conservation of energy and momentum. Then later, Fermi, he has named the third particle as neutrino. So what does neutrino stands for? Neutrino is nothing but it is a little neutral one has been termed as what? Neutrino. So they didn't form, they are theoretically by assumptions only everything they are what? Predicting it, and they are saying that there is a third particle will be existing in that equation, and the third particle only carries the discrete energies and momentum. Therefore, they named that third particle as what? Neutrino, and they said that the neutron is nothing but what? It is a little neutral one. This is a little neutral one, and they say that the neutrino has no charge. Neutral, they are saying neutral no, so therefore they are saying they have no charge, and the mass is also very less in nature. So in 1931 they revealed and they have predicted, and theoretically they have analyzed and they named it and later in some year later, so neutrino has been given the symbol called nu. So nu is a Greek word, nu, N-U, right? So we have to pronounce that nu. So it is a Greek word. We have been given the symbol called what? Nu. Later in 1956, so experimentally they found or detected neutrino. Right? So here theoretically they have predicted, and later in 1956, Frederick Reis and Friday Howard experimentally found the neutrino present in there. And for this, Frederick got what? A Nobel Prize in the year of 1995. Right? So they have found experimentally, they have detected and they have seen how they have detected electrons, protons, and neutrons. Like that, experimentally, they have detected and they found what? Neutrino. For that, Reis got Nobel Prize in the year 1995. And later, many experiments physics the properties of neutrinos. What is the property? Already, what they have been theoretically predicted, the same property will be that. So it has zero charge, that is neutral in nature, zero charge, no charge, and it has an antiparticle. An antiparticle is called as what? Anti-neutrino. Antiparticle is called as what? Anti-neutrino, and they have mass is what? Very tiny mass. So since it is very tiny mass and it has no charges, it interacts very weakly with the matters. So its interaction will be what? Very weak, and experimentally it is very difficult to find the mass because it is very small in mass and has no charge. So experimentally it is very difficult to found the neutrinos. And they are saying that every day trillions of neutrinos have been released from the sun and it is passing and interacting with our bodies. But since it is a very tiny mass, we are not able to realize the interaction. So that is called as what? A neutrino. So beta decay has revealed a new particle called what? A neutrino, which is a third particle, and they are saying that what? Third particle in beta emission, right? Not as third particle in some other way. So third particle in a beta emission, and they are saying that it is a no charge, it is a very tiny mass, and it will be interact very weakly, right? So daily trillions and billions of neutrons has been passing through our body. So from the sun's radiation, but we are not able to realize it. So that mass, very tiny mass of that, we call that type as what? A neutrino. Is it clear to you? So in beta decay, they realized that in conversion of neutron into proton, they said only electron has been emitted. Later, they found that the thing has been violating the conservation of energy and momentum, and they found that they had a question. The puzzle has been later clarified by the person scientists, and they found that there is a third particle existing in the equation. They named the third particle as what? Neutrino, and they have given a symbol called what? Mu. And the properties have also been discussed here. So we have been thoroughly learned about what? The alpha decay and the beta decay. So along with the beta decay, we have learned about another thing called what? Neutrino. So each thing is a separate 5-mark question for you. So alpha decay is a 5-mark question, beta decay process is a 5-mark question, neutrino and its properties is another 5-mark question for you. Right? So next we will see about what? The gamma decay. Right? So if the gamma decay over, then the radioactive concept will be clear to you. Right? So at last, we are going to learn about the gamma decay. So we have already learned about what? Alpha decay, beta decay, and now we are going to learn about a gamma decay. So what is a gamma decay? We have seen in the introduction. It is nothing but it is only the energy release. So there will be no change in its mass number and atomic number. So if we say alpha decay, we can say that the mass number will be decreased by 4 and atomic number will be decreased by 2. If I say beta decay, we can say that the mass number will remain the same, but the atomic number can be increased by 1 for electron emission, can be decreased by 1 for beta, that is what? Beta minus, that is positron emission. Is it clear to you? So beta plus decay and beta minus decay. So it gives electron emission, we can call it as a beta minus decay. If it gives positron emission, it is called as what? Beta plus decay. Can you able to analyze that? So now we are going to study about what? Gamma decay. In gamma decay, there will be no change in mass number and atomic number. It will remain the same, but there will be only energy will be released. How it will happen? So gamma decay will not separately occur. It will occur along with the alpha decay or beta decay. When alpha decay or beta decay to take place, it will come down from an excited state to a ground state. So if it's directly coming to excited to ground state directly, there is no other emission of energies. Instead of that, it has been given to some other higher energy state, then there will be a decaying of energy from higher state or metastable state to a ground state. So during that conversion, there will be what? Energy will be released in terms of photons. Right? So that is the concept. It's a very, very interesting concept. If you understand, if you see this diagram, you can easily able to understand. So everything, every condition there will be a levels. So as in chemistry, how we are studying B's and K, L, M, N, levels of R, S, P, D, F shells. Like that. So everywhere there will be a levels of that. So even if you take us also, we are in a normal state. We will do our routine work or so on. Suppose if we are going for a tour for 1 week, so we will be very energetic and very and we will jump here and there and we will pack everything and we do. Our activity will be more higher than the normal activities. Right? So that is called as the excited state. So normal state, so daily routine work, same work. That is a normal state. Excited state means a happiness. Right? Or we are going to for any functions that is very, very important for us. We will be very excited. So we will dress nice and everything, isn't it? So that is said to be our excited state. We will not be at the entirely will not able to be in an excited state. After that function or a tool program has been over, we have to return back to the normal routine life. We call that as a normal state. Right? Similarly, the atoms or nucleus also will have different level of excited states or a ground state. So ground state is a level in which everything is a stable one. If it has any energy has been accrued by it, it will jump to the higher energy state. So higher energy state will not able to live for a long time because the lifetime is what? Very, very less. It is 10 power minus 11 seconds. After that time is over, it has to automatically jump to what? A ground state. While it is jumping to the ground state, it will release all its energy in a form of a radiation. We call that as a photon. Is it clear to you? So everyone will be in the ground state. By hearing news, we are going for a movie or we are going for a trip. So we will jump it over. Right? We will be more energetic, right? We will be in the excited state. After that thing has been happened down, so we will return to home in a very less energetic way, like that. So we will lose all the energies in that celebration. No? So like that. So excited atom when it drops to ground state, it will lose all its energy in a form of a radiation. We call here as a photon of radiation. So photon means it will represent a symbol called what? H nu. Is it clear? So H nu, we call this energy of emission as what? Gamma emission. Right? So remember it. So if an atom is jumping from excited state to a ground state, the energy will be of the order of few electron volts. The excited nucleus is moving from excited state to ground state, then it is of the order of million electron volt. It will be more. Is it clear to you? So there are different levels of state. Right? Always the excited state is what? Short lived. What is meant by short lived? கொஞ்ச நாள் தான் இருக்க முடியும். ரொம்ப நேரம் அங்கேயே இருக்க முடியாது. Right? So automatically it has to jump to ground state. The ground state jump பண்ணும்போது now it will release all its energy in the kinds of radiation called what? Photon. Right? So the alpha decay and beta decay is taking place. Means while that. So instead of going to a ground state, if it is jumped to some other higher excited state above the ground state, means from the excited state to the ground state, it will release its energy in a form of what? Gamma rays. Now we are moving to a very, very important and standardized questions called law of radioactivity. So already in the last video we have been discussed about the three kinds of decay, that is alpha decay, beta decay and gamma decay, right? So that is said by Suri and Fatima, right? So here also Suri and Rutherford has been stated the law of radioactivity. That in alpha, beta and gamma decay we have taken out one single element and we have studied about how it is undergoing decay. Suppose if it is having more amount sample of amounts, so it is a very high radiative substance has been weathered means, then that type of disintegration, how to learn that? So they had a thought about that and they have started in theoretical calculations and they arrived at equations to calculate the amount of disintegration nuclei present at any time. Right? So from the time t equals 0, from the initial to any time, we can easily able to calculate the number of undecayed nuclei which has been present at any time. So that type of derivation is called as what? Law of radioactive derivation. said by Sudi and Rutherford. Is it clear to you? So decay process has been explained by both Sudi and Franklin. Here it is explained by Sudi and Rutherford in order to go for a sample of substances. So they have followed the same probability conditions for calculating the amount of substances. So they have taken a sample of substances in terms of what? Disintegration. Right? So we'll go for it. So at any time t, the number of decay per unit time, we call that as what? Rate of decay. So number of decay per unit time. For a given time, how many amount of number has been decaying? So look at that, the number of decay per unit time. Right? We will call that as what? Rate of decay. How far? With respect to time. With 5 minutes, how many things has been decayed? At next to 5 minutes, how many has been decayed? So with respect to time, the number of decay in calculation is called as what? The rate of decay. It will be a present form of differential equation dn by dt. So d by dt is a differential format with respect to time taken, and n stands for the number of a undecayed condition. So they are saying that at any time t, right? At any time t, they are saying that the rate of decay dn by dt is directly proportional. So you have to differentiate between proportional and alpha. So here in short I have written as what? Proportional symbol here. So it is directly proportional to the number of nuclei present at that instant. Right? So if I give you, let me tell you an example, right? If I give you 10 chocolate, how many chocolate you will eat? So we can eat more than 5. If I give you 2 chocolate, how many chocolate you will eat? Only 1 or 2 chocolate. So the amount, how many chocolate we are eating depends upon what, how many chocolates we are having in our hand. Is it clear to you? So like that, we are saying that the rate of decay means what? Aழிவறை. So எவ்வளவு கடையில் போகுதுன்றத பொறுத்து இருக்கு. அந்த நிமிஷம் எவ்வளவு அளவுக்கு நம்ம கையில இருக்குன்றத பொறுத்து இருக்கு. Radioactive substance எவ்வளவு அளவு. So it directly depends upon என்னது? Number of nuclei present at that instant. அந்த டைம்ல எவ்வளவு amount of nuclei இருக்கு. உங்க கையில எவ்வளவு amount of chocolate இருக்கு நீங்க சாப்பிட போறீங்க. 10 இருந்ததுன்னா 5 சாப்பிடலாம். 2 தான் இருந்ததுன்னா 2 தான் சாப்பிட முடியும் இல்ல 1 தான் சாப்பிட முடியும். So that depends upon எவ்வளவு அளவுக்கு அழிக்க போறோம் சாப்பிட போறோம் அப்படிங்கறத பொறுத்து இருக்கு. என் கையில என்ன வச்சிருக்கோம்ன்றத பொறுத்து இருக்கு. The same concept related here. So that is what? The rate of decay. Can you able to understand that? Yes. So we are going to write this statement in the form of equation. So we are saying that dn by dt is directly proportional to what? The number of nuclei present at that time. So automatically what will happen? If a proportional sign is that means we will make it as a constant value. We will put as equal by introducing a constant. Here I will represent it by negative sign because it indicates that the number is going on decreasing with respect to time. If I have 10 chocolate, the first day I will eat 2 chocolate. The second day I will eat 3 chocolate. So the number of having 10 chocolate will go on reducing to a 0 value, isn't it? So the number is going on reducing like that. So minus sign represents that the number of atom which is decreasing. And the proportional constant is said to be what? Lambda. We call lambda as a decay constant. We call lambda as what? A decay constant. So we'll rearrange the equations. We'll bring this dt to the side. So the equation 1 will be rearranged as dn is equal to minus lambda n into dt. But dn is said to be what? The number of nuclei decaying in the time interval dt. How much is going to disintegrate in that time interval dt. Is it clear to you? So that is it clear? So what we are saying? In order to calculate the more amount of samples, how it is undergoing disintegration, we are following a condition called what? Law of radioactivity. According to law of radioactivity, we are saying that the rate of decay is directly proportional to the number of nuclei present at that instant. So the statement has been written in the form of equation, and proportional sign has been given in terms of a constant value, and we are representing minus sign. Why we are representing minus sign? In order to say that the number of atoms goes on decreasing with respect to time taken. Then after rearranging the equation we get like that. Then we are saying that if the time is 0 second, when it is the standing period, we can say that n will be equal to n naught. What does it mean by that? The number of atom will be equal to what? N naught. That is the initial time. So the total number of atoms which is present in undecayed condition is said to be what? N naught. So n is what? At that time, what is the amount of substance? N naught is what? At when the initial period, when it is started over, when it is packed over, what is the total number of nuclei? It is said to be what? N naught. So when time equal to 0 second, n will be equal to what? N naught. So in order to calculate the undecayed nuclei at any to integrate the equations for the limit n not to n. So we'll write the equation. So what is the equation? dn by n. We'll rearrange it. We'll put everything to be one side. dn by n. So dn by n is equal to what? Minus lambda into dt. I'm going to integrate this equation, right? So the limit n not to n and 0 to t. If you integrate this equation 1 by n, it becomes log n, right? So log n equal to what? N by n not upper limit, lower limit, minus. Here it becomes to what? T. Integration of dt becomes to be t. Lambda is constant, therefore minus lambda t. Is it right? Right. So we are going to substitute the upper limit and lower limit. It becomes to what? N log n minus not n naught. So it is on the form log a minus b. So how to write log a minus b? Log of a by b. Right? So we have taken the equation. We assumed every condition to one side. dn by n equal to minus lambda into dt. Then we have given integration sign, the limit. So n means n not initial value is n not, final value is n. Time means initial value is 0 and final value is what? T. Then if this is of the formula, integration formula to the value of what? Log n. So upper limit minus lower limit. Here I didn't represent that. We know it because so if the integration of dt becomes to be t. Upper limit minus lower limit, if I substitute, it becomes to be what? T equal to 2, right? So then shortly we are writing as what? Minus lambda t. Then when we substitute the limit, it becomes to what? Log n minus log n naught. So it is of the form log a minus log b. So log a minus log b form as what? Log a by b. So log a by b n by n not equal to minus lambda t. Very simple and very easy when you understand it, right? Then what we are going to do? We are going to take exponential on both sides. We are going to take what? Exponentials on both sides. We take exponential of both sides. This log will get cancelled and therefore n by, we say that n by n naught is equal to e power minus lambda t. Right? This will get cancelled. So n by n naught will be equal to what? Exponential of minus lambda t. If I bring this n naught to the side, we get n equal to n naught e power minus lambda t. So this is our main equation to calculate the number of undecayed atoms present at any instant t. Right? So that's simple the equation is. We call this equation as what? The law of radioactive decay. Well here the n stands for the number of undecayed nuclei and n naught stands for the number of nuclei present at initially, and the time t is equal to what? 0 second. Here at the time t. Is it clear to you? Very simple. Note it here. Again you see the derivation. So we are saying the statement the rate of decay is directly proportional to what? The number of decay. So you are writing that as an equation. Then proportional sign has to become to be what? Minus. So it is the introduction of constant minus lambda. Why minus? Because the number of atoms decreasing. Yes. So lambda is called as what? Decay constant. We are rearranging the equations and again we are rearranging. We are assembling all the same terms to one set. It becomes to be dn by n equal to minus lambda dt. Now we are integrating the equation with the limit lower value to higher value. Then we know that this formula is what? Log n and this is what? Lambda t. So log upper limit minus lower limit. Then we are having from log a minus log b because to be log a by b. Then we are taking exponentials on both sides. So this log will get cancelled and therefore it gives the equation n equal to n naught e power minus lambda t. This n naught goes to the other side. It gives the equation equal to what? N equal to n naught e power minus lambda t. We call this equation as what? The law of radioactive decay. It's a very important standard 5 marks which has been frequently repeated in your all examinations, right? Then we are saying, what we are saying, n is nothing but what? The number of undecayed nuclei and n naught is said to be what? Number of nuclei present at initially, that is t equal to 0. The important thing here we have to note it what? The number of atoms decreases exponentially here e comes, right? So n is what? Number of atoms present at any time. So it is exponential with respect to lambda t, decay process and time taken. Therefore, the number of atoms, how it is decaying, it's not randomly decaying, it is exponentially decaying over the time. And therefore, we are saying that the time taken for all the radioactive samples or nuclei to taken will be what? It will be infinity. So it will go on slowly decaying to an infinite period. So it will be prevailing for a long period of time. So that is called as what? Law of radioactive decay. So we are drawing a graph here, right? So time is along x-axis and number of undecayed nuclei along what? Y-axis. a graphical representation represents the law of radioactive substances. Is it clear? So it's a very